Hey, Miss Marion here. Let's go ahead and go through Unit 5, Lesson 1 through 6 quiz and see what we need to go ahead and fix and understand to go ahead and retake the quiz. So here is number 1. Number 1's kind of self-explanatory. So we're putting into the function is divide by 2 and then press enter and then add 1, press enter, and then you find your final answer. So we put in 0, we're going to get 1. We put in 2, we get 2. Put in -8, we're going to put -3, and then 100, put in 51. So remember, when we were doing these in class, you do have to do divide by 2, press enter, and then add 1, press enter. You can't just put them all in at the same time because sometimes the calculators don't understand what you're exactly trying to do. So do each step one at a time. All right, number 2, you're told that you have to wait 5 hours in line with a group of other people. Determine if you know the number of minutes you have to wait. And so you had a choice between yes and no. Yes, if you knew the number of hours you have to wait in line, then you can determine the number of minutes you'll have to wait in line, right? Or no, if you know the number of hours you have to wait in line, then you cannot determine the number of minutes. So we know the conversion of hours and minutes, right? It's 60 minutes per every hour. So then if you have so many hours, you can figure out how many minutes you're supposed to be. So this is just more of a logic thinking kind of thing. Here is number 3. Number 3, you're told, again, you have to wait for 5 hours in a line with a group of other people. Determine if you know how many people have to wait. And so do we know anything about the line? No. So no, if you know how many hours you have to wait in line, you do not necessarily know how many people were in the line. You don't know how long those people are going to take. They may take very short amount of time, or they may take a long amount of time. So just because of knowing as far as the hours does not mean that you know how many people were in line. So that's why it was no. On number 4, you were told that you have to, again, wait in line for 5 hours. And then we're going to kind of put the two different statements together. So it depends on the number of hours you wait multiplied by 60. So that is going to go is the number of minutes you wait depends on the number of hours you wait multiplied by 60. So these two will actually go ahead and go together. So like this one goes with number 1. And then the number of people that have to wait cannot be determined from the information. And so those two will also go together. So like 3 and 4 kind of go together as far as the questioning of it. All right, here is number 5. So we have an input-output diagram where we are understanding as far as what it is itself. We want to make an equation. So remember how we were doing the equations themselves. Some of us, we do start with, so this is our rule, right? Remember, this is our rule. And we want to make an equation. So we have it as 25n is our rule, and it's always going to equal this, the output here, so V. So if we flip-flop that, we're going to have V equals 25n. These are exactly the same kind of thing, just one right after another. All right, number 6, again, we're dealing with the input-output diagram about the V equals 25n. It says find the output, so pretty much find the end result if we have our input is 10. So like 10 is going to be here. We're going to put it into our rule. Our rule is 25 times n, which is going to be 25 times 10. And then that is going to be 250. So we're just using the input-output diagram to understand how we can put things into this and then get our answers back. Here is number 7. Again, we have the input-output diagram. Quarters and cents is a function of n, the number of quarters that you have, right? So if we have so many number of quarters, we can figure out how much money we have. It says identify the independent and dependent variable. So remember that our input is here, output is here, right? So remember that our input is our independent variable, and our output is our dependent variable. So the amount of value is going to depend on how many quarters we actually have. So independent, dependent. All right, number 8, here's a graph of a function showing the amount of money remaining on the subway fare card. So that's just a card to go ahead and go on the subway, which is the subway, right? So the subway fare card is as a function of the number of rides taken. So what is the output of the function when the input is 10? So we're going to look at 10. So this is our input is 10. So what would be that output? That pretty much is this point here. Our output is going to be 20. All right, number 9, again, we have that same graph. Subway fare car, we have a function of the number of rides taken, right? And then number 9 is asking what is the input of the function when the output is 5. So we kind of read it backwards. So our outputs, remember, is always our y-axis or our dependent variable. And so we're going to look at 5. And then what is our input that goes along with it? Well, really much we're looking at this point here. Our input is going to be 16, because remember the input or the independent is on the x-axis. All right, number 10, still kind of the same thing. We're actually going to kind of read some stuff. We're actually talking about this point here and what it actually means. So we have 7, 2750. Well, what does that mean? So let's go ahead and label it. So remember, we always have it as an x, y, or it's the independent variable and the dependent. Okay, so if we label it, we have the number of rides and then we also have the dollars, right? So let's put the numbers in there. So for 7 rides, it's going to be $27.50. So which one would go ahead and go with it? After taking 7 rides, there'll be $27.50 remaining on the card. All right, number 11, Diego runs a 10-kilometer race and keeps track of his speed. So as you can see, the speed is changing depending on where he is in his run. What is Diego's speed at 5-kilometer mark place? So our input is 5. So we have, this would be 5 here, right? And so then what goes along with that? That his speed would be 10 kilometers per hour. Kilometers per hour. All right, number 12. Again, same picture. Diego, he's running 10-kilometer race. How far is he going? The distance. According to the graph, where was Diego when he was going the slowest during the race? So remember, if we're looking at this is our speed. So the slowest is like the lowest, right? So we're looking at that lowest point. Where is that lowest point? Well, that's here. So how far is that? That's going to be 3 kilometers. So 3 kilometers. All right, so moving on. Again, the same thing. So number 3, well, question number 3, but it's number 13, right? It says, describe what happened to Diego's speed in the second half of the race. So we're looking between 5 and 6. So between here. So what happens? So if you look at it, going from kilometer 5 to kilometer 6, he's going faster, right? He gets to the 6 kilometers, and then he ends up it's going down, right? So then it's going slower. So which one's going to go with it? So from kilometer 5 to kilometer 6, Diego went faster but slowed down between kilometer 6 to kilometer 8. He sped up again. So faster. Okay. And then he finished the last kilometer at the same speed. So this is same because it doesn't change. So it's going to be the second one for our answer. All right, number 14. Let's read the story. So Elena starts to walk home from school, but she has to turn around and go back because she left something in her locker. On her way back home the second time, she runs into her friend who invites her to the library to do homework with her. She stays at the library and then heads home to do chores. Determine which graph fits Elena's story. So really what we have to look at is we have to look at the labeling. This is the distance from Elena's home, right? And then distance from Elena's home. So she was at school. So kind of think of it as like if the house was sitting here, right? if she's at school, you're going to start way up here. This one, if you're thinking the house is here, this is where she starts at home. So starts at home. That wasn't our question. That wasn't our story. She started at school. She started heading home, right? Went back, got something, started heading home again, went to the library, stayed there for a while, and then eventually came home. So the first picture is actually better. All right, number 5, same story about Lena walking from home. So which quantity is a function of which? So remember, I don't have the picture on here, but we had the distance from home, and then we had it the time, like time elapsed. So we're looking at it as function of which, remember? So remember how we did like distance from home depends on the time. Okay, so we know that the y-axis is always our dependent, right? X-axis is always our independent. And then what we're going to do is we're going to take out the word depends and we're going to say function, right? So distance from home is a function of the time, or the time lapsed. So that's why the first one actually is our answer. So hopefully going through this quiz, you understand what you got right and wrong. We will have about a week to go ahead and retake this quiz. So go ahead and start studying for it, and then I will set out when it will be due. So have a good day. Bye.